Hello and Assalamu alaikum everyone. My name is Arsalan Farrukh and I teach math and physics. In this particular video, I will discuss different formulas for the equation of a straight line. So if you have to find the equation of a straight line, there could be different situations that may be provided to you in exam. Like one of the formulas is y is equal to mx plus c, which is also called gradient intercept form, where m is directly the gradient or the slope of the line and c is specifically the y-intercept of the line. So if you know the y-intercept and you know the gradient, you can write the equation directly into this form. Like for example, if you know that the gradient is -2 and intercept is known as 5, so you can, in one step, you can directly state the equation of the line as y is equal to -2x plus 5. This form is also useful in situations where you are given the equation of straight line and you have to find the gradient and y-intercept. Like for example, if you are given an equation in the form 2y plus 3x is equal to 5 and you have to find out its gradient and y-intercept. So you can rewrite this equation into this particular form: y is equal to mx plus c. In one step, it's going to become 2y is equal to minus 3x plus 5. In the next step, it's going to become y is equal to minus 3 upon 2x plus 5 upon 2. I've cross multiplied 2 on the other side. So by comparing this with this particular form, I can directly see that the gradient is minus 3 upon 2 and y-intercept is directly 5 upon 2. Another form that may come out to be useful in exam is the point and the gradient form, which means that you know one point on the straight line and you also know the gradient of the straight line. The formula is y minus y1 equals mx minus x1. X and y would be part of the equation, so you leave them as it is. X1 and y1 are the x and y coordinates of the known point on the line, and m is the gradient of the line. So for instance, if you have to find the equation where you know the gradient to be 3 and you know that it is passing through any point, and in this case it's -1 and 5, so you can apply this formula. Y minus y1, y1 would be 5, so it becomes y minus 5 equals m. M is the gradient, and in this case the gradient is given as 3. X minus x1. So x is part of the formula minus, and x1 is given as -1, so you write -1 with its sign, of course. So you simplify this, it's going to become x plus 1, and hence you will get the equation of straight line. This is the equation, but you can obviously simplify it, write it into a more simpler form. So I multiplied 3 with x plus 1, I got 3x plus 3, and then I rearranged it, and my simplified form is going to be 3x plus a. Another form that is used a lot is like a situation where you know both the intercepts. You know the x-intercept and you know the y-intercept. So you can remember this form as x upon a, the intercept of x-axis, plus y upon b, the intercept of y-axis, is equal to 1. Remember, there is 1 on the right hand side. In the denominator of x, you have x-intercept, and in the denominator of y, you have the y-intercept. So if you know both intercepts, you can directly state the equation. For instance, if you know that a line is passing through a point 3, 0, so that means that is going to be your x-intercept, and also a point 0, -2, that is going to be your y-intercept. So you can directly in one step write down the equation as x upon the x-intercept, which is 3, y upon the y-intercept, which is -2, and that is equal to 1. And then you can again simplify this equation by obviously taking the LCM and rearranging the equation. So this is going to become, if I take the LCM, this is going to become 2x minus 3y, and 6 gets multiplied on the other side, and this will be a simplified form of that equation of straight line. One last form that can be useful for you is when you are given 2 points on the line, and that formula is y minus y1 over y2 minus y1 is equal to x minus x1 over x2 minus x1. Y and x are still part of the equations. They will stay as it is, but you will identify one point, one coordinate pair as x1, y1 and the other point as x2, y2. So once you have identified, and it really doesn't matter which point you take as x1, y1 and which point you take as x2, y2. But once you have chosen one point as x1, y1 and the other point is x2, y2, you just need to place that into the formula. In this case, I'm considering x1, y1 as 1 and minus 2 and x2, y2 as 3 and 1. I can also switch them. So y minus y1 would be negative 2. Over y2 minus y1 would be 1 minus negative 2. Similarly, x minus x1 would be x minus 1 and x2 minus x1 would be 3 minus 1. So once I have written it down in this form, again it just is a matter of simplification and you will be able to get yourself the equation straight line. So 1 minus minus 2 is 1 plus 2, or that simplifies as 3, and similarly 3 minus 1 simplifies as 2, and then I have cross multiplied the terms and got myself the simplified form of these. One more important thing that you may find useful when you're finding out the equation straight line is the relationship between the gradients of two parallel lines and two perpendicular lines. So if you have two parallel lines, then both lines have same gradients, equal slopes and gradients. So if you know gradient of one line, you can copy that as the gradient of the other line as well, if it is known fact that both lines are parallel. For example, I've been given this equation as equation of one line. I have to find equation of another line which is parallel to the first line but passing through 1 and minus 1. What I can derive from the fact that the two lines are parallel to each other is that I can take gradient of one line and put it as the gradient of the other line. So if I know that this has a gradient 2, I can use that as the gradient of the other line. And then what I'm going to do is that I'm going to use that gradient and apply the formula to find out the equation straight line. Other thing that you must know is that if two lines are perpendicular to each other, then the product of the gradients is equal to minus 1, which also means that the gradient of the second line is negative reciprocal of the first line. So what you can do, if you know gradient of one line, you flip it over and you multiply it with minus. Like for example, if you know that one line has a gradient 2, the other perpendicular line has a gradient 1 over 2 with a negative sign. Or if one line has a gradient 1 over 3, the other line will have a, if it's perpendicular, will have a gradient minus 3. Or if one line has a gradient 2 over 3, the other line will have a gradient minus 3 over 2. So you just flip it over and then you multiply it with the minus sign. Hence, you will be able to get the gradient of the other line. Now, if I know equation of one line, I need to find out the equation of another line that's perpendicular to the first line, and I know it passes through a known point which is 2 minus 3. So first I figure out that the first line has a gradient 4. I flip it over and make it negative, so the gradient of the perpendicular line would be negative 1 upon 4. So once I have the gradient of the perpendicular line and I also have the point, I can use the formula to find the equation of straight line. Y minus y1, which is minus 3, and equals m, which is for the new line negative 1 over 4, x minus x1, and that is going to be x minus 2. So once I have this equation, I can sort of simplify it, rearrange it, and get myself the equation of straight line. I hope the video was helpful for you. If you did like the video, please like and subscribe to my channel. Thank you.